Hi guys, Ben from Think Fencing here. What I'd like to do right now is show you an example of a customer supplying some details for their fencing project, how I work out the fall in regards to what angle it is, and then how we go about the custom programming. So the customer here has a fence run of overall 62 metres that way, 3.5 that way. So this is plan view, bird's eye view looking straight down. We've divided into 3 sections because they've got a high spot about 2/3 of the way down from the left. So they've given us the 40 metre stretch with a 1210mm fall, and on this side it's 22 metres with a 1360mm fall. Section 3 is just no fall. So the customization we need to know is like what post offset, and then also for the rails, the top rails, what offset for the rail so that the picker can go through. So first things first, we'll start with section 1. So over here on our program, we're going to change the height. So the height in this case is the 1210mm fall. And the width is 40 metres. So I'm working in millimetres here. Now, let's just scroll out that little bit. Okay, so over that distance, we've got a 1.73 degree. And then we'll work out section 2. So we've got 1360. And a width of 22 metres. And you'll see that we've got a 3.54 degree fall. Okay, so to make it a bit more interesting, we're going to work on section 2 here to show you what we do as far as post offsets go. Here I need to put in the fall in degrees, so we're going to work off 3.54. Now we've got a high and low side, so in this case this is the high side being 0, so effectively it's actually doing that over that stretch. If we're standing here, that's us, hello, looking forward in front of us, that's an exaggerated version of what's going on. So we're looking at this section here at the moment, okay? Generally speaking, if I just convert this back to 0 degrees for a second, this is if you give us no information, we do even both sides of the post, same height, so 50mm down, 50mm down, whereas when we go back to that 3.54 degrees, tick, it needs to pivot from the center point of the post. So we've got to split the difference of the offset. So we've got 46mm on one side, on the high side is 46mm, and high side, and then the low side will be 53.7. Okay, so what we're going to do here is put in our fall details to work out the picket offset on the rail. So we've got a 3.54 degree slope. And you'll see here, this is going to be your 76mm picket going plumb. And our rail is going with the slope of the land at 3.54 degrees. We actually need to have a 5.3mm offset for the cutout for the picket on both sides. So our rail offset is going to be 5.3mm. So that just means if the rail is there, if we were to be, that's 90 degrees, the cutout going through here, we've got to be this way on the bottom plus 5mm, 5.3mm. So it'll go from here to here. So you got 77mm at the top. That'll be 77mm, but it is 5.3mm over. So I also wanted to show you another example of, this is plan view here. This is very common in a rural setting where the street's running this way, the road, and people want a nice leading entrance off the road coming into their driveway. So quite commonly, we just do a 45-degree angle, or 45's actually there, where we lead in. And we need to know, when we drop a post over here, you want all your street front posts to be square to the road. And in this case, there'd be 5 posts there and there. And then also at the driveway entrance, we need them to be, you want them squared all parallel to the road, correct? So what we need to do is work out how wide the cutouts need to be. And I'm going to show you how we do that over here on the computer. So in this scenario, we know that we need to, on one side, that's your rail. So what we're going to do here is change this angle to the 45-degree. And you'll now see the rail coming in actually needs a longer cutout. So the data that we need is right here. So on this side, the rail's coming in square to the post, so it only needs to be plus 1 millimeter to give it a little bit of float. And then on this side, we know that we need 75 millimeters. So we'll have our 51 mil cutout on one side and 75 millimeters on the other side, just to give it that little bit of float around the rail and get it in without struggling to get it in there. Now, the orientation of this post is actually universal because they're parallel to each other. So although in this example it looks like it's only going that way, that same post with that programming can be used on both entrances of the driveway. And again, to be able to have our entrance post square to the road, we actually need to have that cutout coming in here to be the 75 millimeters to allow the rail in on that 45-degree angle. So that's what you should expect to get in your pack. We've got all the information required to then program each cutout for the router, the CNC router. So obviously we've come up with this sort of custom drawing, which we can work out the calculations to the millimeter very quickly, but then there is also programming involved, and then the operator on the CNC router will need to have multiple programs and additional work as far as there'll be different programs that need flipping over, etc. So it adds a bit of time. You do pay a fee for the customization, but it makes the install so much smoother, and the results are just streamlined, like it's made to order. So that's the custom side of what we work out when you provide a drawing.